So here we go. With the time we have, let's do some logarithms. All right, so we have, there's 21 questions, so we're not going to get through them all, but let's do what we can. Let me rewrite this one for you. So we're in 12.5, number 1, log base 4 of 1024 equals 5. Okay. What in the world? Have you done logs before? I'm assuming not. I'm assuming this is brand new, first time logarithms. They're actually not that bad. Let me explain. What they are, first off, is the opposite or the inverse of exponentials. That's why we're doing them together. 12.3 was exponentials. Now 12.5 is logarithms. Now what do I mean when I say exponentials? Let's be super clear on that, and that'll make logs be easier. Exponentials means things with powers, right? You know, exponents. So logarithms are the opposite of that. That's why they have a number lower down. See how that 4, that's not just me writing badly, although I do write funny, but that 4 is the base. It's lowered down on purpose. Again, just like baseboards are low down, that's a base number. Now it's made to make you think about powers. See how that kind of looks like 4 to the 1024 power? It's not really that. It's actually the opposite of that. But it's made to make you think that way. You want to be thinking about powers, a low-down number, something on it. That's the idea. Logarithms are exactly the opposite of exponentials. They made them up. I don't know if you know, all of math was just made up to describe things that are real. They had real-life exponential problems they're trying to solve. You go into higher math, take pre-calculus, you'll do some exponential, financial, chemistry, biology, all kinds of things in the real world are exponential, and they solve them with logs. They need logs to solve them. So anyway, let's get down to what they do. So what they're asking us to do on this question is they're just wanting us to get familiar with logs at first. And so we're just going to practice translating languages. Kind of like, I can say 1 in English, 1. And they're saying, write as an exponential. So in other words, it's like me saying 1, can you please say that in Spanish? Okay, uno. So we're going to say the same number, different language. Let me write that out for you. So write as an exponential. Okay, so how do you do that? So I want to get rid of the log word, in other words. I want to say the same truth in another language. How do you do that? How am I going to get rid of that log word? Well, remember what I said about logs. They're the opposites of powers. So it's kind of like, what happens if you get bit by a snake and you got poison in you? What do you need? And yeah, you need the opposite, the antidote. Also, the word went out of my mind. Thank you, Manuel. Antidote. We need the antidote, right? Well, that's what logs and powers are. If you want to get rid of the log, you got to do the antidote, the opposite. What's the opposite? Powers. Okay, but what power? What base? Same base. So what's the base on this log? 4. So you do the exact same thing to both sides, meaning you do 4. Now notice that 4 is low down, and same thing over here. It's not next to it. In other words, I didn't write that 4 like right there on the level with the log. No. It's a base, like baseboards are on the floor. It's on the floor because it's doing the power thing. What will that do? That'll get rid of this. It'll get rid of the log and his base. Gone. All at once. Because that's the very definition of what they are. They're the opposites of powers. They made them that way on purpose. So that later you can solve other things. Anyway, good so far? Yeah.
Is that in front of the 5?
Yeah, it's in front. So it's 4 to the 5th. So these are gone. What's left? 1024 is 4 to the 5th power. And we're done. That is the same truth in the exponent language as the logs was saying in their language.
So the 5 becomes normal.
What's that?
The 5 becomes normal for the 5th.
The 5 becomes normal?
Well, I mean, it becomes an exponent.
Yeah, right. You're right. It becomes an exponent. Right, because the 4 came in as a base for both of them. Does that make sense? Because that's what makes it cancel. Powers are the opposite of logs. So if you bring in the same base as the log has a base, it'll cancel it out. Whatever you do to one side, you have to do the same thing to the other to keep them equal. Right? Let's try another one. So number 2, log base 10 of 100,000 is 5. Okay. Log base 10 of 100,000 is 5. So that 10 is lowered down on purpose. And notice the way I say it. Log base 10 of 100,000 is 5. Right? That's a base. Okay. Same thing. They want you to change out of that log language. So what's going to get rid of the log word? 10 base, both sides, right? 10 base power, both sides.
10 to the
100,000 equal to 50.
So I'm going to put a 10 as the base on the left, but whenever you do to one side, you have to do the other to keep them equal. So what happens? These cancel. Because bases and powers and logs are opposites. As long as the bases match, they will cancel. So what does that leave me?
100,000.
Yeah, 100,000 on the left side, other side. It's just 10 to this. See, these all cancel, huh? And that's a true fact, isn't it? 10 to the 5th, 10 times 10 times 10. Every time you multiply by 10, it adds a 0. So it makes sense that, 10 to the 5th is 5 zeros. Huh? That's a true fact. And the logs are saying that's what we were saying all along in our language. That makes sense? We're just changing. We're just getting used to log talk now. Changing languages between log and regular or exponential. All right, let's try number 3. Rate the following as an exponential. Oh, yeah, that's weird. All right, they're doing something kind of weird. Right as exponential. Okay. So do you see how that? What's the low-down number? What's the base? It's E. E's actually a number. I don't know if it's a special number. Don't even worry about it. It's kind of like pi. Just know it's a special number. It's 2.7 blah 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 blah. Special number. Okay. Whatever. We don't care. Whatever it is. Whatever is lowered down. Whatever the base is. How do we get rid of the log? We just use that. Both sides, huh? So I'm just gonna go, okay, so I'm going to put an E here. I know it seems weird because there's like already a couple E's, but that's what we do. Same exact thing we did before. Whatever's lowered down, below, whatever the base of the log, whatever's right next to the G in the log word, right, lowered down, we do that on both sides, cancels out, and so what does that leave us? Well, that leaves 1 over e to the 9th is e to the minus 9. That's our answer. That's a true statement, isn't it? Remember how negative powers flip things? We would look at that and go, yeah, we know that. And the log would say, well, that's what I was saying in his language. That's good. We just don't speak that language naturally, so it looks bizarre to us.
So the first E is going to stay at the base? It's going to stay on the bottom? Like that?
So these guys cancel.
Mm-hmm.
What do you mean by first E?
So,
This one?
No, down, below.
This?
The one, yeah. So whenever...
Yeah, whatever. So notice the pattern.
So the
Look,
1/9 is going to be the exponent?
look right here. So whatever's right next to the G in the log word, all of that cancels and everything else drops down, huh? So that's what happens every time. All of these cancel and everything else drops down. So same thing.
So whenever we write the answer, it's going to be E with the exponent of 1/9?
That's...
Or is it just going to be 1/9 with the... I mean, it's kind of like the same thing, but like when you write...
Oh, yeah, no, you can't make it like that. That's different. That's a different animal. Yeah. Yeah, it was never that, right? It was always 1 over e to the 9th. Yeah. All right, so number 4, same thing. Let's go the other way now. Let's jump to number 5. 8 squared is 64. So I'm going to jump to number 5. So 8 squared is 64. Now they want me to write as a log. So now I'm going from uno back to 1. So now I'm going the other way. They're starting with something that's I already am more comfortable with. A power statement. 8 squared is 64. That's obvious. We know that. 8 times 8 is 64. Well, they want me to write it as a log. Now, how am I going to do that? Well, what you have to do is you have to do log on both sides. So I'm going to do log. Now, when I write log on both sides, I'm going to write log on this side, log on that side. Now, whenever you write log, you have to have a base. There's no such thing as a log without a base. There has to be a low down number down here at the bottom of the G. So what do you think we're going to use?
8.
Same base we had here. This is the base, right? This is the thing that has a power on it. He's the base. So it's log. So I'm going to log base 8, both sides. Got to be the same thing on both sides. So that's exactly right. Bring down the the stuff that's already there. Now, what do you think's going to happen there on that left side? These guys are going to cancel, aren't they? Because remember, when they match, just like right up here, right? When the base and the log base match, gone. So this is just going to be 2 is log base 8 of 64. And that's the statement they want. That really says the same thing as 8 squared is 64. It just says it in log speak. Is this making sense? So if you have a log, you power both sides and it cancels. If you have powers on both sides, you log both sides. So these are antidotes, aren't they? If you have one, you do the other, and they cancel each other out. Let's try number 6. E to the 5 equals x. So number 6, e to the 5 equals x, write as a log. So try that. Okay, so how am I going to write it as a log? I got to do the same thing to both sides, right? I'm going to log both sides. And what base am I going to do? Yeah, the base that's already there. Log base e on both sides. And this is e to the 5th, and this is x. Good so far? And what happens on the left side? These cancel. When a log with the base and the power match, those things cancel. So this is just 5 is log base e of x. And we're done. That's what they want. We're saying, we haven't solved anything. We've just translated. Like 1 to uno back to 1. That's all we're doing. Is saying the same truth, the same fact in another language. We're just changing between log speak and power speak. Exponential language and log language. Yeah.
How do you enter that in Math Excel?
Yeah, so you'll just have to put that down. There's one of the things on the template lets you put lower numbers. So you have to put that down and then put this back on the level. Yeah, so the E is just lowered down. Everything else is on the main line. They'll let you do that. There's a template for that. It's a little tedious. All right, so we did number 6. Okay, so try that one. So they want me to write as a log. So write as a log. So what base? Base 2, huh? There's always a base down there by the G. Always. And now what happens on the left side? These drop, huh? So minus 3 is log base 2 1/8. Getting easy? Change between those two languages, between exponential and log. So if you have a log, you power both sides, same base. If you have a power, you log both sides, same base. And they always cancel out on the one side. Okay, now moving on into number 8. They want me to do log base 8 of 64. So now they want an actual answer, not just a translation. Do you understand the difference? We just shifted gears. We're not just we're not saying, hey, rewrite this in another language. No, they want an actual answer now. So how do we do it? Well, if you have numbers like this, let's grab our calculator. Let me show you how to do this on the calculator. So grab your calculator. Do you find the log button? You see the log button on your calculator, L-O-G? We're going to actually turn this into 2 logs. So this is going to become log 64 over log 8. It's kind of a little bit of a long story. I'll probably talk more about it on Wednesday. But for now, just the one that's on the top goes to the top. Make it 2 logs. The answer should come out 2. Are you getting 2 okay? So just like this. Just type that into. So make it into 2 logs. So when you have 2 numbers like that, you actually make it into 2 separate logs like that. Make sure you close the parentheses on the top and the bottom before you hit equals, and you should get the answer. Number 9. Log 125 of 5. Can you try that one? So the one that's on the top, because a lot of times students will ask me, Mr. Trent, how do you know which one goes to the top and the bottom? The one that's higher up goes to the top. The one that's lower down goes to the bottom. And the answer you should get is 1/3. Maybe 0.33333. Does it show it that way, or comes out a fraction on some of the nicer calculators? So you should get 1/3. You able to get that? Or 0.33333, which you can convert to 1/3. So when you have a log, you make it into 2 logs. I know I haven't given any reasons for this yet. I'll try to do that more on Wednesday. But for now, you make it into 2 logs, and the number that's on the top goes to the top. The bottom goes to the bottom. Top to top, bottom to bottom. Like that. How about log base 8 of 1? Try that one. Same kind of thing. Top goes top, bottom goes bottom. So the top goes top, the bottom goes bottom. Isn't it 0? Should be 0 on that one. Cranking these out okay? What if they're going to try to trick you on number 12. They're going to go log base 2 of 32, and they're going to go equals x. Well, who cares? Equals x. Call it Joe, call it Tom, call it x, call it y, whatever. All you got to do is the same thing we did on the last few problems. You just got to let the top go to the top and let the bottom go to the bottom, and you should get 5. Is that coming out okay?
If we're able to input it in there, it should be fine, right?
Yeah, all you got to do is put it into your calculator, yeah. Okay, now coming to number 13, I know we're getting close to running out of time here, but I wanted to show you that there will be a little more work to do on 13. It's going to say log base x of 196 equals 2. Log base x of 196, I probably need a fresh screen on that. So log base x of 196 is 2. Let's end with this one. I think, are we doing okay? We're doing okay. We still got a couple minutes. Yeah, we're okay. Okay, so now this one we're going to have to actually do something. Now, in other words, do you see first off that we can't just right now hit the buttons on our calculator? Why not? Why is it we can't just calculate?
Because we don't know the value of x.
Yeah, we don't know that because we have an x here. See how that's different than the others? Here we just had 2 numbers, 2 numbers, 2 numbers. So if they just give you 2 numbers on a log, no big deal. Just make it 2 logs. Top goes top, bottom goes bottom. But if one of them is an x, right? One of them is an x. I can't put x on my calculator. So what am I going to do? And plus they're giving me something on the right side, which is kind of weird. So what was it? It was x 196. So what am I going to do? How about this?
Make the basis equal.
Yeah, get rid of. Christine's saying let's get rid of the log. That's exactly it. We need to get out of this language. We don't speak log naturally. How could we get rid of that log word? Remember, what's the opposite of logs? Powers. Powers are the opposites of logs. So if you have a log in there and you want to get rid of it, power both sides by the same base, right? So what's the base? Yeah. What do you do to one side? Do to the other? Gonzo. So that gives us 196 is x squared. See how we got out of the log language by doing that maneuver? And now, there's no more log word. We can solve that. How do you solve for x with that? Just square root it, huh? Yeah. So you just square root. Is it 14? And we got it. Normally we go plus or minus when you put a roof in a house up in a ladder, but you can't have a negative in a log. It's only regular positive 14, not the negative. You can't have a negative in a log. Here, we still got a minute. I want to do one more. Let's try. Oh, no, that'd be too easy. 14's cake. 15. Oh, those are easy. 14, 15 are cake. So I'm going to jump to 16. So yeah, let's do 16 right over here. So 16, the next one where you have to actually work. All right, let's finish with that one. Try that one. Same kind of thing. We don't have two numbers next to the log. If we did, we would just hit the buttons on our calculator. But we don't. So get rid of that log word. How are we going to get rid of that log word? So I'm going to x base both sides. These cancel out. We good there? So 8 is x cubed. That first move makes sense. Just power both sides. Cancel out the log. So then can you solve that one by observation? X to what power? Yeah, what to the third power is 8? 2. Yeah. X has got to be 2. Solved by just looking at it. Yes. Good. We got pretty far.